Hello, this is Todd Danielson, the Editorial Director of Informed Infrastructure. Today I'm speaking with Stephen Baldridge, the president of Baldridge and Associates Structural Engineering, BASE, which he founded in 1995. We're going to be talking about the recent Champlain Towers collapse in Surfside, Florida. But can you start by providing a brief summary of your education, career, and current position and role?
Okay, my education started with a bachelor's degree in civil engineering from the University of Wisconsin. Actually started working after that and went to night school at the University of Illinois, Chicago, studying pre-stress and post-tension concrete design. And then went back to school full-time to get my master's at the University of Texas. Worked in Chicago and Texas for a while before eventually moving to Hawaii, where I finally started a firm called BASE, which has grown now to a national and international firm with offices in Hawaii, Chicago, Florida, and Guam, and India.
Can you summarize your initial thoughts about the Champlain Towers collapse, knowing the investigation is just beginning and actual data are scarce?
Yeah, so it was interesting because we were talking in the office a little bit about how design was done historically and how design is done now. And sometimes you have nice little rules of thumb where you can kind of look at things and get a good idea of where you're heading, if you're heading in the right direction. And interestingly enough, the city there made available on the internet existing permit drawings for the project. So opened those up and started taking a look at them. And I'm like, wow, that span appears to be pretty long for the thickness of the slab up in the towers. And then also, which seemed a little bit odd, but might have been the case back then, the concrete strength was fairly low, at least what was indicated in the permit drawings. So it initially kind of caught my eye and going, that they might have something that's called punching shear stresses that could be kind of on the high side.
Because of what appears to be progressive collapse, what do you believe to be the main contributing factors?
Well, of course, this is going to take some time to really see what happened there. And unfortunately, a lot of the evidence is going to be at the bottom of the rubble pile and may actually be destroyed, whatever video evidence there is. But having the existing drawings provides a blueprint to model the building and see if the building itself may have had some design weaknesses that could have contributed to the ultimate progressive collapse or disproportionate collapse of the building.
What might forensic engineers examining the collapse be looking for to determine the cause? What did they do?
So with the drawings, I said you can start to model the building from top to bottom. And then from those models, you can see, hey, does it meet code today? Did it meet code back then? From the rubble pile, you can actually start to test some of the materials to see what was actually constructed. Was it constructed with the right strength concrete? Was there a little reserve capacity? Maybe this concrete, a lot of times it comes up higher than specified. Hopefully find some of the reinforcing steel at the base of the building and see if there were any signs of excessive corrosion. In particular, maybe in some of the columns and beams at those lower levels.
Obviously, they had to for safety, but they recently collapsed the whole building. Will that make it more difficult for them to find things out?
Safety of the USAR teams that are out there is paramount. There's so many things in play right now, whether it be trying to rescue anyone who might be left, trying to retrieve the remains of loved ones, and then of course the people on the site day in and day out who are actually at risk on that rubble pile. So it's a shame that they couldn't preserve that building, because it would have been a very good way to see what was going on in the existing building. Were there any areas where maybe something was overloaded, whether it's in the parking or somebody's unit? Very, very easy way to verify what was permitted was actually built. But safety is number one priority. There is, I understand, another similar building down the street that was built kind of by the same team. So you still have something that you can go back and look at.
I know that after you looked at those drawings that were made available, you did some hand calculations and 3D analysis using software based on those building plans made available by the city. Can you share what you found?
Sure. I mean, the initial hand calcs actually showed that there were some punching shear stresses that were on the high side. And we wanted to go back and see, you don't want to kind of bring that up without taking a closer look at it. So we modeled the floor slab in a 3D analysis software. And actually, it appears based upon loads that would have been used for the design that there might be some punching stresses that are actually exceeding code allowable. And now you're starting, which wouldn't necessarily cause failure, but now you're starting to eat into the safety factors that are inherent in the code that provide some reserve capacity. Another key and important issue as well is back then, analysis methods that were available were fairly sparse. And the codes were in the, well, one thing that was added to the code after that design is something called structural integrity steel. And that was a result of other collapses that had occurred, such as the Murrah building in Oklahoma City, and finding ways to make a building more resilient and redundant and provide alternate load paths. So if you do have failure of a column, ideally you don't have failure of the rest of the building. And at that point, no buildings had that in there as part of the design. It would be something that creates a weakness in the building under a catastrophic loading scenario like this. We looked a little bit more through the drawings and found a couple other things that were a little bit concerning. And again, you're not looking to point the finger or blame, but it's something that's worth taking a look at in more detail and analyzing the building as it was built or as it was permitted. Shear walls in one direction of the building were pretty short, and there are only two of them. So what may have happened too is if something failed somewhere else in the building and started pulling the building sideways, the slab column joint would have now been helping with lateral capacity in the building, which could have overloaded the columns and the slab column joint in punching shear. Of course, I'd imagine over 40 years, this building has been through some decent wind occurrences, so it must have enough capacity for that. Some of the witnesses who were in the building once said the building swayed like a sheet of paper. And that may have been due to the fact that the shear walls in one direction were really pretty sparse. The other thing that we noticed is that some of the columns at the base of the building retained their small size and were very heavily reinforced. And if special mechanical splices weren't used for that vertical reinforcement, by code, they actually might be considered over reinforced, which is not necessarily a good thing. Sometimes too much rebar is not a good thing. So getting concrete consolidated around the rebar and the splices gets difficult with the more steel that you put in there. And judging by some of the photos, there was punching shear failure at the ground level. So it could be that one of those smaller columns, once it lost the lateral support of the slab, all of a sudden under that high compressive load, it wanted to buckle sideways, was nothing to keep it from moving. And that could have led to loss of a column and then collapse throughout the building.
What are high punching shear stresses and punching shear failure, and how may they have been a factor in this collapse?
So a flat slab, this is from the permit drawings at least, this appears to be a reinforced concrete flat slab, about 8 inches thick in the tower. And all the loads from that slab have to somehow get from the slab into the columns that support them. And there's essentially a zone or a ring in that slab where you're looking at the shear stresses as those loads transfer into the column. And if there's not enough thickness or there's something else going on at that joint, you can actually have a shear failure. And it's very unfortunate because shear failures don't give much warning and the results are very catastrophic. So for example, if you have flexural overstress in a beam, you'll typically see the beam starting to deflect too much. You'll see cracking appearing in the bottom of the beam or maybe in the top of the beams at the support, but you have some warning that something's going on, just like they did with some of the corrosion. But in a punching shear failure, oftentimes would be very catastrophic and it would just happen. And what happens at that point is loads have to start redistributing to other columns, which can overload them. And saw a recent picture at the ground floor that showed that there was punching shear failure of the parking deck. And then what happens at that point is the columns at the lower level now are spanning twice as tall as what they were designed for. And they could actually buckle in that situation, leading to collapse of other areas of the building.
Hypothetically, if you were leading the forensic team for this collapse, what would you do?
Well, the first thing is you just have to respect the process of rescue. So if, without deterring that process, if you can start to collect pieces of data as you extract rubble from the pile looking for survivors, that'd be an important part of the process. Once the rescue efforts are completed, then you want to start going into the pile and collecting whatever data you can. And some of that might be collecting samples of concrete to see what is the actual strength of the concrete that was in place. You can look for reinforcing steel, make sure that the steel was of the right grade of steel as specified. Is there evidence of any columns where you saw significant corrosion in vertical reinforcing that would have reduced the capacity of columns? So you have to start sifting through the rubble, hoping to find intact pieces that you can actually take a look at and determine what was going on.
Once they figure out what happened to this particular building, what should engineers be looking for to learn from this event going forward?
Well, it's really going to determine what they find. I mean, if they find that there were, design deficiencies that contributed to it, maybe in Florida, when they recertify a building, they may want to have engineers also go back and look at the design for a few key elements of the building that might lead to a collapse like this. I think collapses, a long time ago, there was a collapse in UK, the Ronan Point building, that the British learned a lot from. In the US, there was more terrorism-related collapses like the Murrah Federal building and Khobar Towers in Saudi Arabia that we learned from. So I think we'll find that the current codes actually probably are sufficient, but there may be some things that you'll learn from this thing about older buildings.
Do you suspect that climate change played a role in this collapse? I heard some talk about that.
Yeah, I really doubt that climate change had anything to do with it. Every building that's on the coast has some exposure to salt water and corrosion. I think they should be able to evaluate that fairly closely and see if there was any weakening of the concrete just due to the salt spray. Again, I think the codes have been updated progressively over the years to address durability, and especially durability in a salt environment. So it'll be interesting just to see. Lower strength concrete actually has a higher permeability to corrosion intrusion. So it'll be interesting to see if there's anything on the upper floors. And then just also to try to figure out were there modifications that any of the owners made to the building that might have contributed to that? Were there any areas of the building that were overloaded and might have contributed? Hopefully they'll be able to find evidence of whether that happened or not.
While briefly sticking to the climate change theme, what should engineers be doing to adapt to changing weather and climate, and how are you adapting in your own practice?
Well, I think the big thing to start looking at is municipalities taking a good look at what they're allowing to build or not build close to the shoreline, to the coast, where you're talking about climate change and you're talking about sea level rise. And I think Miami has already started doing that, but you want to allow buildings to be built a little bit taller and raise the ground floor and make sure that you have the ability to address sea level rise as it becomes an issue. Climate change for itself, all the studies that have been done on weather are historic, so it's very difficult to predict in the future, will that have a change to the severity of tornadoes or the severity of hurricanes without having the data to figure that out.